This animation is intended and features present are by no means design methodologies. Block caving is a low-cost and low-development underground mining method that can be used to extract ore from massive low-grade deposits. Shown currently is an ore body that is to be extracted using block caving techniques. The development of a block caving mine is relatively simple compared to other methods. Displayed is an example of a block caving mine layout that might be used to extract an ore body such as the one shown. Block caving is suitable for massive ore bodies that will break up and fragment when caved, but are strong enough to allow initial developments to be constructed and cost-effectively maintained. The shape or outline of the ore body should be relatively regular, with steeply dipping or vertical sides. Block caving enables low-grade deposits to be extracted at high extraction rates for low production costs. However, a significant amount of underground development needs to be completed prior to the extraction of any ore. This feature negatively affects mine economics. The initial underground development in the mine usually consists of lowering the main declines, shown in green, and the sinking of major haulage and ventilation shafts, shown in blue. Shafts usually serve as a transport route for both supplies and the workforce, or to bring the mined ore to the surface. They are also commonly used for ventilation purposes. Access and ventilation drifts, as shown in orange, are constructed at certain levels to provide access to various locations such as crusher stations, ore bins, or to the primary development areas. The dimensions and shape of the openings is somewhat dependent on their use and the type of equipment that will operate in them. However, typical drive dimensions range from around 4 metres square to 4 metres high by 5 metres plus wide in high traffic areas. Typical shaft sizes may be around 6.5 metres in diameter. Crusher stations, ore bins and other workshop rooms can also be constructed underground. When the access drives are in place, raise boring can commence to construct the ore passes and other raises. These are shown in yellow. Once access has been completed, development on the production and undercut levels can commence. On the production levels, production drifts are drilled and blasted along the length of the area to be caved. The spacing of these depends on the design and geology of the area, however 25 metres is an average figure. Crosscuts are driven between these drifts every 10 to 15 metres or so, and, in this example, take on a herringbone formation. These crosscuts will form the draw points, with the angled entrances allowing easier access for the tyre-mounted LHD excavators. The undercut level is situated above these draw points. It is usually developed at around 10 to 15 metres above the production level, and consists of drifts, shown here in blue, that run parallel and directly above the production drifts below. Once the production and undercut drifts are completed, construction of the draw bells can commence. The bells funnel the broken ore into the draw points during production. In this example, blast holes are drilled from the undercut level and draw points. These are then blasted, with the broken material being removed to form a funnel. Illustrated is one of several variations of draw bell geometry and construction. The exact design of all underground developments will often vary, depending on the area geology and the production requirements. However, concrete lining is often used, particularly around the draw points, as artificial support is often needed for the weak rock inherent with these operations. Surface installations such as the shaft head frames and winch buildings, ventilation fans, surface workshops and other facilities must also be installed before production commences. Finally, when all development has been completed and all production is ready to commence, long hole drilling is performed in the roof of the undercut level into the ore. These holes are then fired, resulting in a volume of blasted ore, referred to as a muck pile, beneath the unbroken ore above. The blasted rock is collected into the drawbells where it is fed into the draw points.